Hi, this is Mr. Patch from North Valley High School. Today we're going to do a lab activity in which we try to show a transfer of energy. What I'm going to do is I'm going to heat up a sample of water here in this beaker and put this piece of metal into it. The metal is made of copper. Eventually this beaker of water is going to get hotter and hotter and it's going to boil. When it boils, it's going to reach a standard temperature that's stabilized, and we'll be able to figure out the temperature of the water. You might think that that's 212 Fahrenheit or 100 Celsius, but remember that those conditions happen at sea level, and we are above sea level about 1,000 feet, so we'd expect it to boil at a slightly lower temperature. We'll record that temperature, and then we're going to put that hot piece of metal, I'm going to use tongs here to do it, and I'm going to place it in another sample of water that I have the temperature of. And what's going to happen is this hot piece of metal at close to 212 degrees is going to be placed in this cool water over here in an insulated container, and it's going to warm this water up. It's going to be transferring its heat energy to this cooler water and warming up this cool water. We should be able to do a calculation to see how much heat the metal loses, because the metal will start off in this temperature of water and end up in this temperature of water. And we should be able to figure out how much heat this cool water gains, because we'll know its starting temperature and ending temperature as well. And those two values for heat should match each other, because the heat the water gains in this foam insulated container comes from the metal. It's the same heat, so it should be the same value. And we're going to check and see if in fact that works out with our calculations. That's our job in today's lab activity. So we're going to start running through our procedures now. First thing I want to do is I want to turn on the balance. I want to make sure that the mass stabilizes, and then we're going to start running down our procedures over here. You're going to have to pay attention to the numbers on the balance, because I'm not going to tell you them. You have to just read them for yourselves. You may have to stop the video periodically to do that. So it looks like the mass is stabilized nicely. The first thing we have to find the mass of is an empty and dry foam cup. That's this thermos here. And so I always zero before I start. And we've got a stable mass. Good. We'll zero it out. Next thing is I need to find the mass of the foam cup plus some water. I've got to put water in here because I'm going to end up putting my piece of metal in there. So I've got a container here. I'm going to put some water in there, enough to make sure I can cover the metal. That's plenty. In many ways, a little bit less is better, because then you get a better result. I'm going to pour a little bit back. I think that'll do it. Okay. So every time I record the mass, I've got to make sure that I've got the top on this. So the mass of the cup plus water. I zero it out, and you can see why. It looks like it's stabilized there. Looks like we've got a stable reading on that. I'm going to remove this. Good. The next step over here, things like the mass of the water, specific heat of the water, we can look that stuff up. The temperature of the cool water in the foam cup. That's going to take a little while, so I'm going to put I'm going to go ahead and put a thermometer in here, and we're just going to let it sit like that for a while. So we're going to come back to this one. And I'm on step 7. The piece of metal in the boiling water. Okay, so I've got there should be some place on here to find a piece of the mass of the piece of metal. Yeah, there it is. Okay. So I'm actually going to skip up to number 13 on this and find the mass of the metal object. Here's the metal object. Once again, you can see we want to zero it out. Looks stable. This is copper, by the way. Copper. Well, let's give it a chance to stabilize. I'm going to remove that copper and I'm going to zero it out and put it on again. And be careful not to breathe on it even. I've actually stepped back a little bit so I'm not breathing on it. I'm going to go with that 1-3. And let's see, we do not have any more mass values to measure. So we are now going to be working on our temperature values. Let's take a look and see how we're setting this up. So there's a couple temperature values we need to have here. Here's one of them. So we've got this container over here, and I don't know that the temperature is stabilized. Sometimes it takes a little while. Okay, we're in kind of the mid-20s. We'll come back and have a look at that in a little bit. So for the ring stand, I've got a thermometer, and I've got it set inside this beaker here. And it's set in the beaker in such a way that it's not touching the bottom of the beaker. All right, it's hanging here down, so it's hanging in the water. So because we want a temperature of the water, not the beaker. The outside of the beaker could be hotter than the water is. So it's going to take a little while for this to warm up. And what I'll do is I'll take this piece of metal and very carefully, without breaking anything, I'll try to drop it in there, and I'll let the piece of metal and the water heat up together. So we'll come back in a couple minutes. So what I've done up to this point is I've taken a picture with my camera of the temperatures because the video camera could not record them very well, but my regular camera could. Set up. So what we have here is we've got a metal in the boiling water. The metal and the water are the same temperature, right? If the water was warmer, then it would be warming up the metal. If the metal was warmer, it'd be warming up the water. So eventually they stabilize to the same thing. So I've taken a picture of that. I've also taken a picture of the temperature in the cool water in the foam cup. So we've got the starting temperature of the metal, and we'll get the ending temperature of the metal. So what I'm going to try to do is take the piece of metal out of this without breaking the beaker and put it inside the foam cup and see how the temperature changes. So I'm turning it off right now. I've already got the temperature of it. I'm going to get ready to do a transfer here. I'm going to try to do it without dropping this piece of metal, which is the last thing I want to do. And come on. Okay, got it in there. Good. I did drop it a little bit, but I dropped it in the foam cup. I don't care too much about that. So what I've got is I now have a hot piece of metal in the cool water here, and I'm just going to make sure that everything's sealed up. It looks like it is. And we'll occasionally look up here and record the temperature. So what's happening is we have a heat transfer. We've got a transfer where the hot piece of metal is placed in cool water and it's warming up that cool water. That's a transfer of heat. The metal's going to get cooler, it's losing its heat. The water's going to get warmer, it's gaining the heat.